Hello, my name is Mark Case, and I'm the Science and Motion Director at Lehigh Carbon Community College. Today, we're going to be taking a look at an experiment to determine what is called the heat of fusion for ice. And this is the amount of energy that has to be absorbed by ice at 0 degrees Celsius as it changes to liquid water at 0 degrees Celsius. So, in this experiment, you're going to try to determine the amount of heat involved in that process that's going to be provided from warm water to cause that ice to melt inside of a styrofoam cup. The calculation that you're going to be using is based on the equation shown on your screen, where Q is the heat flow or heat energy that's going to be lost by the water but gained by the ice. The amount of energy for water is based on its specific heat capacity, which is the capital C sub P as a symbol. And this requires the amount of energy for a gram of water to change by 1 degree Celsius, which is equivalent to 4.18 joules. This is also equivalent to the older method of using units of calories. So small c calories, 1 calorie is the amount of energy that causes 1 gram of water to change by 1 degree. So 4.18 joules, one small c calorie is equivalent in terms of energy values. The M is the mass of the water that you're working with, or the mass of the ice you're looking at. It will be involved in the calculation of the heat of fusion. And the triangle T, or Greek letter delta T, refers to the change in temperature that occurs. So our objectives for this experiment is to actually determine the heat energy change in joules to cause 1 gram of ice to melt. It's going to be looking at calculating then the units in kilojoules per mole to cause that ice to melt. So instead of 1 gram of ice, a mole's worth of H2O as a solid is going to be 18 grams that you're melting. The equipment we're going to be using is shown in the diagram here. And basically, that's going to be utilizing a temperature probe. We're going to be using a styrofoam cup, using a beaker maybe to help stabilize it, perhaps a stirring um, apparatus that you might have, a stir station or a magnetic stir to try to mix that up, or else you just have to sort of swirl it around as the temperature is changing along the way. You can either determine the amount of mass of water and ice by approximating it with the volume, where 1 gram of water is about 1 milliliter based on density, or you could use an actual balance to be able to set that up. So your teacher will share this procedure with you. We're going to have to go and open up graphical analysis on your particular device, whatever that might be, whether it's a PC or Mac or a Chromebook or an iOS device of some kind or an Android phone or device. You can get this download from Verniers Graphical Analysis on their website. And if you need some help with that, your teacher can provide that information as well, which will be part of this package and this setup. So let me set up the lab. You'll be able to read this because you'll have an electronic copy of it. And you'll have to be able to make some measurements and some recordings and put those into a data table. So you can discuss that later about what information is critical and what do you need to know. From this video, you'll be able to figure out everything that would be necessary to do your calculations later on. So let me switch over and take a look at using, let me close this up here and hide this for a moment, and take a look at using graphical analysis, which I have on a split screen here set up on the side. And then I have a balance in the screen where I have a video of that so we can see what we're going to be measuring as we go. So I'm going to look at what is the mass of a styrofoam style cup with a lid. And then we'll also need some kind of temperature probe. So I'm going to be using a Vernier Go Direct temperature probe. For now, I'm just putting it on top. There's nothing inside this cup at the moment. So you can write down what that initial mass is of the cup, the lid, and then also the temperature probe. We're going to have to turn on the temperature probe. So if you press and hold the button here in the center, it'll start flashing. Now it is sending out a Bluetooth signal. If I come over here and I do sensor data collection on my graphical analysis, what it will do is it will try to see if it can find where that particular sensor is. And if there's multiple sensors that are out there that are turned on, you'd have to know what your particular ID number on your sensor is so you can connect to that. So I'll connect to it and link to that device. And now that means that we're ready to go and start our particular experiment. So I'm going to hit the done. Now they say that in this lab, instead of doing 180 seconds, as you can see here, we want to run this for 480 according to the directions. So I can just go and I can click at the bottom of the graphical analysis, and it will let me change the settings for my length of time during that setup. So it's going to run for 480 seconds. Right now I'm going to take my cup and I'm going to add to that some warm water that I heated up in the microwave. I'll dump that in, put my lid on and my temperature probe down inside, and we'll set that on here and we're good to go. So what you'd have to record here also is what's the mass now with the water that has been added to it. So the water I'm looking at with the beaker and the lid and the temperature probe is 216.7372 grams. You know, it'll fluctuate a little bit sometimes back and forth. On my scale over here, what I can see is what my temperature value is. If you can't see that large enough, you can actually click the three dots on the upper right-hand side here, and you can change how large that's going to show up in your presentation mode. You don't want to make it too giant because then it gets all clustered together. But I can see that my temperature is now at about 58.2 for my start of my experiment. What I'm going to do is I'm going to begin collecting data since that temperature is fairly constant, 58.1. So let me start with that. I have some ice in another cup. What I'm going to do with that ice is I'm going to dry it off with some paper towels. And the reason why I want to dry it off with paper towels is I want to get primarily just the ice going in there, not a lot of the water that has already melted. Let me set this down for a moment so I can get this open easier. So I'll dump my ice down inside there. Put my temperature probe back in as quickly as I can. And you can see the temperature is taking a very rapid dive during this experiment. I can swirl it every so often just to try to distribute the temperature and have that equally balanced. I should take note of what my new mass is because I have now just added to it some of the ice that's there. So the new mass looks like it's about 299.47, somewhere in that ballpark. Let me swirl it a little bit more here, try to distribute that heat. If you have a magnetic stir, you can put a stir bar down the bottom and keep stirring this up, make it more uniform. So I'm getting a pretty ugly looking graph, you know, wobbling back and forth because of not stirring it consistently. But that's okay because of the fact that I'm just looking at the net change in temperature, the overall difference between the starting temperature and the final temperature. You can still hear a little bit of ice chunking around in there. Now, if it gets to a point that you've added so much ice to it that your temperature ends up getting down to 0 and you can keep swirling, 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 and the ice is not melting, well, then what you might have to do is remove some of that ice and then not count that in the mass of the ice that was actually melting, because not all of it would melt. So it looks like I'm starting to level off somewhere around, 12 degrees or so. I'll let that sit for a slight bit longer. Notice that even though the temperature has dropped, that doesn't affect the mass, because that's still the same amount of matter that you have in there, whether it be in ice form or as liquid water in terms of your setup. If this would run long enough, what'll happen is that the temperature will begin to start to climb again once all the ice is melted. And now as it starts to reabsorb some energy from the surrounding environment, it will eventually warm back up to room temperature if you leave it sit long enough. And room temperature is probably, normally around 20 degrees or so, depending on if you're in a warmer environment, a colder environment, what your status is, of your room temperature that you're dealing with. But 20 degrees, 18 to 22 normal temperatures that you might have in a lot of places. So I'm going to let this go for just another 50 seconds or so. It said 480 seconds, but I think we can see what's happening here, that it's not really going down anymore. That's the most important part that we're concerned about. Has it reached the maximum change in temperature from the high point to the low point? And then from that stage, we can do our analysis of the results. We can figure out what the total mass is of the ice that melted, what was the mass of the water that was used, what was the change in temperature that occurred, and complete our calculations as part of our lab analysis. Now, one thing that could have happened while this is running is that you'll notice up here in the upper right-hand corner, this has what's called the Graphical Analysis Pro version. So our Science in Motion program has actually purchased a site license that will allow teachers and their students to use this and share their information directly as they're running the individual experiment. So this is set up already for data sharing, and it gives you an ID number that you would then use in terms of connecting your device to the teacher's computer, this computer that's actually running it. And basically what I would do on there is I would set up graphical analysis, see if I can get a good vision here. So I have graphical analysis on my phone. A little bit out of focus, but you sort of get the idea of what's here. I'm going to do data sharing. And when I click on data sharing, what it's going to do is it's going to connect to the same device. It's going to actually link to the device that the teacher is using. So it's going to ask me to connect to this. Let me see if I can zoom in on that a little bit better for you. Sometimes it's very difficult to be able to get a good image off of another screen. Let me do an autofocus on there. And I would put in that ID source that I mentioned. So I want to be able to enter what that source number was. And for this particular trial, it's VSN 9GY. So when I enter that information in, hit connect, if we're both on the online, you can see that I now have just received that data, And because it's being collected live, it's also being sent to me and collected live in the process as well. So if I stop collecting data over here, then I'll be all done with the data and I can do my analysis from there. Now on the teacher computer, they could click on, any one of these points and be able to take a look at what the high value is, what the low value is. They could also come over and use the graph tools, which will allow them to view statistics. So I would get all the statistics and be able to figure out what that delta Y is from my data. But you'll notice that the student doesn't get that on their device. They would have to go and do the same thing on their device and say, view statistics, and then they would get that data as well, which should match up pretty close if you're just talking about the overall data of the information that's there. So they would then do the analysis on their own. So that's the experiment. Your teacher will help talk to you a little bit more about what you might need to do to get things complete. Let me just go back and take a look at the data table that you might use. So let me go back to my Word. When you got a lot of stuff opening, sometimes it's hard to get to that data that you want to find. So I want to go to the Word format. So here's your data table that shows you your initial information that you should be providing. What was your water temperature initially, the final temperature, the change, what was your volume of water or mass, since we know the mass, and then what was the amount of mass that was actually melted. If you were doing volume, then 1 gram to 1 milliliter would be the density that you'd work with. Your calculations can figure out the numbers that are there. The known heat of fusion of ice is that it takes 6.01 kilojoules to cause 1 mole of ice to melt. So in this case, you can actually see how close your data comes to that of the accepted value. You'd want to consider what are sources of error, things that might cause your value to come out lower or higher than what you actually ended up getting, and how you might be able to improve your percent error and find a more accurate measurement. So thanks for listening. Hope you have a good lab experience and a good day, and stay safe. Take care.